Hello, this is Irma Baker, welcoming you to our show. We're sponsored by RSVP, the Retired Senior Volunteer Program, which is a part of Mature Services. According to the dictionary, a kaleidoscope offers a constantly changing group of bright objects, and that's what we hope to do with these programs. We're bringing you interesting people, organizations, and activities in our viewing area. After these messages, we'll be right back with today's guest.
RSVP of Summit County has been making a difference in our community since 1972. RSVP volunteers are increasing the quality of life by participating in programs and organizations that provide important services to the community. RSVP matches personal interests and skills with opportunities to serve. If you're interested in adding more meaning to your life and improving the lives of others, please call 330-253-4597 extension 166.
Welcome back. Our guest today is Dr. John Szabo. Dr. Szabo is chairman of the Department of Geology and Environmental Science at the University of Akron. Dr. Szabo, so nice to have you with us today.
My pleasure to be here.
Well, I'm glad because you're going to be talking to us today about a subject that has fascinated me for many, many years. Ever since I was an undergraduate myself, I was interested in the geology of our area. I find it just fascinating that we're on this borderline between the mountains to the east and this flat land to the west. What really caused that?
That was caused by several glaciations which occurred over a period of maybe 2.6 million years. It's estimated there's been like 24 to 36 glaciations during that time period. And what we are seeing is sort of the end effect of all those glaciations. We have records for the last few glaciations, but anything older than that we don't have near the surface anymore.
When you say glaciation, are you telling me that we've had more than one glacier through the area?
We've had many glaciers through the area over the last couple million years.
Oh, you can tell how much I remember from that long ago class. I thought there was just one big glacier that came down and made the big lake here.
Well, the one big glacier formed up in Canada many, many times and came down into Ohio. What we see is basically the record of the last two that are fairly well preserved in Ohio.
What impact did they have on us here?
One of the largest impacts is the change in the drainage systems. Before the glaciers came, there was a large river called the Taze River that began down in North Carolina. Okay, you see the Taze River began in North Carolina, flowed across part of Virginia through West Virginia. It takes its name from the town of Taze in West Virginia. Enters down near the border of Ohio and West Virginia, flows northward towards Columbus, then sort of west-northwestward over towards Van Wert. It then continued across Indiana and Illinois into an ancestor of the Mississippi River. The area generally to the south of us here drained into the Taze. The rivers in our area drained to the north through a system called the Aragon River system that went north across Canada. So there was a glaciation that occurred sometime before 800,000 years ago that dammed up the Taze River system, causing these very, very large lakes in front of the ice. These lakes filled up in the valleys of southeastern Ohio and eventually spilled over the high divides and flowed southward, forming some of the beginnings of the Ohio River. Certain segments were formed at other times, but that's sort of the initial phase of the Ohio River system. And as the ice melted back from this early glaciation, a lot of the drainage continued to the south, especially in the south central part of the state.
Well, it sounds to me like this involved a lot of research, a lot of study. Was there anyone who was really, that we can credit for coming up with all this information?
There was a person back in the 1940s named Carl Van Stieg, who sort of looked at a lot of well records all throughout Ohio and was able to reconstruct this drainage system. Later on, people became interested in these lake clays that were present in the valleys in southeastern Ohio, and a person in Ohio State actually sampled them and determined that when these lake clays were deposited, the magnetic field was reversed. In other words, back beyond 800,000 years ago, there was a time at which your compass would point south. Now, the way this works is that when you have a lake and you have particles of sediment floating around the lake, as they settle out, any sediment containing iron particles will orient itself with the Earth's magnetic field as it settles to the bottom of the lake. So what a geophysicist can do is go back and take samples of these lake sediments, unwind the magnetism, and determine which way those little sediment particles were pointing as they settled into the lake. And there's an 85% chance that the magnetic field was reversed at this time. We know that these reversals occur quite on a regular basis on Earth there. We see this in the geologic record of the lava flows along the mid-ocean ridges. That's how this paleomagnetism was originally discovered.
Well, I've heard the name Milankovitch or Milankovitch.
Okay,
What was his involvement in all this?
Well, Milankovitch was trying to figure out why the Earth went into these glacial phases. So he started looking at the geometry of the Earth-Sun relationship. And he came up with three factors that influence the amount of radiation received by the Earth. The first is that the Earth's orbit's shape varies from an ellipse or an oval to a more circular orbit. In some modes, like the elliptical mode, the Earth would swing farther out for a while in this stretched out orbit, and that cycle occurs roughly every 100,000 years. He then looked at variation in the tilt of the Earth's axis. That's referred to as the obliquity to the ecliptic. It's quite a mouthful, but we're essentially looking at the tilt of the axis varying from 21 degrees to 24.5 degrees. And you can look at this in terms of how much radiation is received in an area. If you take a flashlight and you hold it straight down on the ground, you get a very intense circle of light. If you tilt that flashlight at an angle, you're going to get an ellipse or an oval. It's the same amount of energy, but it's spread over a larger area. So as the tilt of the axis changes, the amount of energy that hits the Earth's surface is going to vary somewhat. That cycle repeats itself about every 41,000 years. The third component to the Milankovitch theory is the precession of the equinoxes. This has to do where the sun is in relationship to the Earth at certain times of the year. Right now, the Earth is closest to the sun during the winter. In 11,000 years, the Earth will be at its farthest point from the sun during the winter, so you might expect in 11,000 years the winters would be quite severe. This cycle occurs on basically a 23,000 year cycle. There's a sub-cycle at 19,000, but usually we like to think of it about a 20,000, 23,000 year cycle there. So Milankovitch then made a graph, and you could see the three cycles plotted against each other, and he said at certain points the least favorable conditions are going to sort of line up, and we're going to swing the Earth into glaciation. So things would get cold. So it would take about maybe 90,000 years to form an ice sheet and only 10,000 years to destroy it. So the last glaciation that affected us here began to form up in Canada probably 100,000 years ago, and it oscillated back and forth maybe at 50,000 and 70,000 years ago. However, it didn't have enough mass or bulk to get into Ohio till about 23,000 years ago. So with this then is the opposite of the glaciation is called an interglaciation, in which climates are warmer than they are today. So 125,000 years ago, the curves lined up to create a climatic optimum. So the temperatures were about maybe 8 to 10 degrees warmer, and that would be degrees Fahrenheit. So at that time, trees such as the sweet gum tree that grow in southern Indiana naturally were growing up in Toronto, Canada. So you can think of Toronto then, 125,000 years ago, having the same climate as southern Indiana. So the Earth swings back and forth through these cycles depending upon the geometric relationship of the Earth and the sun.
Wow, this is something that when you're talking about thousands and hundreds of thousands of years, it really is mind-boggling.
Oh,
you know,
yes.
and to me, when I'm thinking about geology, I'm looking at the rocks that I can see or the hills that I can see. When I traveled west towards Indiana, you just mentioned Indiana,
Right.
it's very flat.
Right.
And I travel east into Pennsylvania, and we have all this mountainous thing. It's very hard for me to grasp the concept that these things were happening, these land formations were developing over thousands and thousands and hundreds of thousands of years. How did you ever get involved in this? What brought you to the study of geology?
Well, when I was young in high school, I did a lot of bicycling, and I had the same questions you had. I know if I headed west towards Lorain County, it got flat. If I headed east towards Pennsylvania, it got hilly. You know, the lake was always up there, so I was sort of curious about that. So when I went to the University of Notre Dame, my undergrad, to study geology, I sort of got very interested in glacial geology. So by the time I got to graduate school at the University of Iowa, I was sort of going along the track of what was called Pleistocene studies, which included the study of glaciers and the study of the other things that come with climate change, such as how the animals ecosystems change, how the biology changes, that sort of an integrated program there. So it's the Ice Age doesn't include only glaciation, also includes the other things that happen with glaciations, which can be quite interesting there if you children have watched the old Ice Age movies that they've had out recently.
It really does make a difference what impacts young people. Mm-hmm. For you, bicycling and noticing the environment around you.
Right.
And I think we're very lucky in Ohio to have the kinds of variety that we do in our landscape.
Well, if we look at sort of the physiography of Ohio, it's split into 4 or 5 areas, and where we are now is on what was called the glaciated Appalachian Plateau. You can think of this part of the Appalachian Plateau looking like southeastern Ohio, which is the glaciated Appalachian Plateau, which is, the unglaciated Appalachian Plateau. So you can think of very rolling topography before the ice got into northeastern Ohio. After the ice left, it sort of filled some valleys in, scraped some hilltops off. So we're high, but we're somewhat more level when we compare ourselves to southeastern Ohio. If you think of going down to Athens, Ohio, down to Ohio University, you can't go there in a straight line on an interstate. You have to follow the hills and valleys once you get off the interstate to get there. Up in this part of Ohio, where it's relatively flat, if we go west of here, we get into what we call the till plains, an area that's been sort of leveled by the glacier, and the land is very, very flat. You can see if you take I-70 across or Route 30 across, you can essentially see towns that are 4 or 5 miles away, the great elevators sticking up or the water towers. That's the Till Plain province, and that extends all the way out to Illinois. So it's just essentially a lowland province in the middle of the United States. In fact, the geologists refer to that as the central lowlands, and then the Till Plains would be a specific subdivision of the central lowlands.
So when you're talking about till lands, that's where our term tilling the soil comes from?
Well, till is sort of a strange material. It's it doesn't really originate from that term. It's sort of a mixture of clay up to boulder-sized material. As the ice melts, the material melts out of the ice. You can think of the glacier as being a big lint roller coming down from Canada, and stuff is getting frozen onto the base of the ice as it moves along. Some of that material is lifted higher up into the ice, so all those granitic boulders we find in people's front yards, they come from Canada. There's what we call erratics. So those are carried up in the ice. At the base of the ice is reacting with the local materials and mixing them all up, and they're frozen into the ice. When the glacier starts to melt, this material then will fall out and sort of just clump together. There's no sorting by water in the case of direct melting from the ice, so you have this mixture of clay all the way up to boulders. And this causes problems in northeast Ohio if you have a septic system, in that if your yard is underlain by this till material, water does not go through it very easily. It goes through quite slowly, and if you were to put your effluent in there, it would just sort of sit there. So environmental protection agencies, the health departments have come up with ways to construct artificial beds for removing the hazardous material, the effluent from the leachate coming out of the septic tanks. And
that is, I'm sorry to interrupt you there, but it's just hitting me. My gosh, things that happened hundreds of thousands of years ago with the glacier when it came over is now affecting my septic system.
It also affects if you have a well. You could have a well into bedrock, or you could have a well into what we call outwash material, which is sand and gravel that originates in a glacial system. And that sand and gravel is somewhat discontinuous, but a lot of the small local farms in rural areas where the sand and gravel is available would use that as a source of water. When the early pioneers came in to northeastern Ohio, they sort of looked for areas that had sand and gravel because they knew they could dig a well into the ground and get an adequate water supply at that time.
I'm really surprised that there is that much influence. When I was thinking of geology, I was thinking of pretty much the surface, just what we see and the changes in our landscape. But from what you're saying, this really goes a whole lot deeper. And you know, while I have you here, I want to ask you about a couple other terms that I've heard. What is a moraine?
A moraine is a ridge of till that's produced at the edge of the ice, what we call the terminus of the ice. You can think of the ice originating up in Quebec, Canada, maybe being about 2 miles thick there, flowing south or southeastward into Ohio. So we're at the very thin margin of the ice, maybe a half to a quarter mile thick. As the ice set here and melted, all this debris melted out from the ice and collected along the edge of the ice. For a moraine to form, the ice has to be stagnant or sit in one place for a long time. So all that big pile of debris forms on the edge of the ice. And as the ice melts back, you're left with this ridge of till, which we refer to as a moraine. There are a couple types of moraines. The kind we have in Ohio are end moraines. The terminal end moraine is the one that is farthest south. It represents the maximum extent of the glacier. Locally, the terminal moraine passes through the city of Canton. The cemetery where the McKinley Monument is, it sits on the terminal moraine. And from there it would loop around down towards Columbus and then out towards Indianapolis and across Illinois up into Wisconsin. The other moraines that are behind that are called recessional moraines. They are formed as the ice is gradually melting back into the Lake Erie Basin. They represent places where the ice has sort of sat for a while and melted. And those are recessional moraines. And they sort of loop around the edges of the ice. So on a glacial map of Ohio, you would see these looping ridges of a somewhat darker color than the background. And in between the end moraines, we would have a layer of till covering the ground, which are called ground moraine deposits. So they sort of fill in the areas in between. Up in northeastern Ohio, we have an area where the ice came from several directions controlled by the topography of the land. The high ground separated the ice into various lobes. So locally here, we are in an area glaciated by what we call the Killbuck lobe, which is sort of centered on Killbuck Creek. There's another lobe that came down through the Cuyahoga lowland just north of Akron, and a lobe to the east called the Grand River lobe, which actually extended out of Pennsylvania but was centered in the Grand River lowland up there in Ashtabula County. Those lobes sort of came together around Akron and north of Akron, especially in the area between the Cuyahoga lobe and the Grand River lobe in Geauga County. So on a glacial map of Ohio, you would see a lot of pinkish deposits in that area. That's all sand and gravel deposits created by the melting glacier of the meltwater just pouring through this area between the ice lobes, flowing southward across Portage County into Summit County into Stark County. And it must have had a fairly high velocity because there are some gravel deposits there that consist entirely of basketball-sized gravel, but no sand in between the gravel. It's what we call hyper-concentrated flow. So very rapid flow of meltwater down south into the Tuscarawas River system, eventually into the Ohio River. Is where some of this meltwater was directed.
Well, I was thinking as you were talking, I'm picturing a beach, but that'd be a pretty rocky beach if you're talking about pieces that big.
Well, the beaches come in at the end. As the ice is melting back towards the Niagara Falls area. It has in front of it a series of lakes that are ancestors of Lake Erie that are trapped between the ice and the end moraine at Fort Wayne, Indiana. That was the first large lake, called Lake Maumee. You can think of it being named for the Maumee River in western Ohio. And a lot of that surface in northwestern Ohio around Toledo are old lake bed deposits. So as you travel to Cedar Point or over to Toledo to go up to Detroit, you're going across an old lake bed. Well, along the edge of these ancient lakes, they existed long enough for wave action to erode the till and create a modern beach, a beach deposit similar to the modern beaches of Lake Erie. If you were to dig into these beaches, they'd be rather coarse, gravelly beaches, not like the mature beaches we would have along the East Coast. So as the water level changed, as the ice position moved back and forth, say through the thumb of Michigan, the water levels would rise, the water would flow through Fort Wayne. If the ice melted back, the water levels would drop and the water would flow out across Michigan. And each time as the water flowed through these areas, it would cut the outlet a little bit deeper, so the lake level would drop in a series of steps, but the steps lasted long enough to create these beaches. Finally, about 12,500 years ago, the ice melted back to expose the Niagara Falls area, which essentially drained the last ancestor of Lake Erie. You can think of it like pulling a plug on the bathtub. All of a sudden, all this water rushes out of this ancestor of Lake Erie, and we drain most of Lake Erie in about a week's time, and the level drops maybe as much as 150 feet. So instead of having one lake where we now have Lake Erie, we had two little lakes, one in the eastern basin off Erie and New York, that's the deepest part, and there was a little lake sitting off of Cleveland in what we call the central basin. The western basin of Lake Erie was entirely dry. And what you need to know is Niagara Falls back at that time was located about 6 miles farther north, and it has eroded back to where its current position since then. The reason we have modern Lake Erie there is because as the ice flowed through the Niagara Falls area, the weight of the ice depressed or pushed the crust down. It was so slowly that the rocks actually behaved like plastic. Instead of breaking, they just sort of flowed downward. When you start to melt the ice, you're taking that pressure off and the rocks start to spring back up. So what has happened over the last 10 or 12,000 years is the Niagara Falls area has risen up and has raised the level of this early Lake Erie, allowing eventually for the lake basin to fill up to get the modern water level. In this early time of early Lake Erie, there was no water coming in from the upper Great Lakes. Lake Michigan, Lake Superior, and Lake Huron drained across Canada into the Ottawa River Valley and then out into the St. Lawrence. So the only water we had in Lake Erie was coming from the rivers. So to give you the example of the impact of the upper Great Lakes is if we were to drain Lake Erie today and then say open a valve over at Detroit and allow the Great Lakes to come in, the upper Great Lakes to come in, it would take 2 years to fill up Lake Erie. If we were to drain Lake Erie and not allow that to happen, it would take roughly 18 years to fill Lake Erie up with river water from Canada and from Ohio and Pennsylvania.
Well, that would certainly make our landscape a lot different. But you've been mentioning places, I'm hearing you, Toronto and Niagara Falls and the Toledo area and all that. And I'm thinking, these are places that most of us, or many of us, visit just as tourists. For instance, this past summer, I went out to Kelly's Island and saw the glacial grooves there. This is all related to what you're talking about, isn't it?
Yes. In parts of the glacier, underneath the glacier, we have erosion occurring. This erosion could pick up previous glacial sediments. It could pick up river deposits from in between glaciations, or it could erode the bedrock locally. So what happened at Kelly's Island was that we've had some large blocks of rock frozen in the base of the ice, and these blocks of rock may have been granitic in origin, we don't know for sure, but they were much harder than the limestones on Kelly's Island. So they cut these large grooves into the bedrock that we see today preserved there. Originally there were many more grooves there, and they were much longer and much more extensive, but they were mined out for the limestone. In addition, these grooves were not only affected by glaciation, they were affected by the meltwater that was flowing under the ice, and these grooves have been smoothed down and even shaped by the meltwater that was trapped beneath the ice.
Well, they are certainly impressive when you travel there or anything. And I think that after listening to you speak today, I think that we're all going to look at our area a lot differently than we have. I've certainly enjoyed hearing you speak today, and I hope that you've enjoyed listening to our guest as well. Thank you so much for watching today's view through our kaleidoscope. We hope you've enjoyed it and that you'll remember our sponsor, RSVP. And RSVP is a part of Mature Services. And RSVP offers adults 55 and over different services and volunteer opportunities here in our local community. For more information about RSVP, just call the number on the screen. For our show today, I'm Irma Baker. Thank you for watching.
Since 1971, RSVP has been matching volunteers' talents to community needs. RSVP is affiliated with the Corporation for National and Community Service, a national organization that supports service and volunteering through grant-funded projects. Volunteers organize neighborhood watch programs, tutor children, renovate homes, plant community gardens, assist victims of natural disasters, and serve their communities in many other ways. RSVP offers maximum flexibility and choice to its volunteers as it matches the personal interests and skills of Americans 55 and older with opportunities to serve their communities. If you're interested in adding more meaning to your life and improving the lives of others, please call 330-253-4597, extension 166.
There's no place like home. Stay in your home with a 24-hour companion that doesn't need to be let outside, who isn't a grown adult reluctant to leave the nest, or a well-meaning neighbor who pops in every day. With Massillon Cable TV's MedAlert personal emergency response system, you can stay home, have peace of mind, and your family will feel better too, knowing you have access to someone 24/7 should you need help. Keep your independence with Massillon Cable TV's MedAlert service. To learn more, call 330-833-4134. That's 833-4134. Or visit their website, MassillonCableTV.com.